Hi everyone, my name is Lydia and this is what I wish they taught me about econometrics and introduction. In the previous video, we saw that when both variables are continuous, the relationship becomes a surface. Now, let's derive the marginal effects formulae, and let's do that by starting with the model as usual, where we've got y equals to beta 0 plus beta 1x plus beta 2z plus beta 3x times z, and ultimately an error term. And as usual, we are going to assume that the conditional expectation of the error term on x or z is equal to 0. So assumption 5, if you remember. That would mean that the conditional expectation of y on x and z is going to be beta 0 plus beta 1x plus beta 2z plus beta 3x times z. So the error term, as usual, has disappeared due to our assumption, and we can concentrate only on what is important for us. If we decide, as usual, to take the derivative, let's try of y with respect to x first, that will give us a derivative that is simply beta 1 plus beta 3z, because these two items in here are the only ones that have an x attached to it. Now, the effect of x on y very clearly depends on z. And z can take many values, which also means, well, now the slope will be different for any value of z that we plug in. If we do symmetrically the derivative of y with respect to z, we'll find that we only have beta 2 plus beta 3x, because the only items in this case that depend on the z are this and this, okay? And the effect of z, what is happening now, is that it depends on x. So the interaction works both ways. Beta 3 measures how the effect of x changes as z increases, or equivalently, also how the effect of z changes as x increases. Okay? So this is exactly where the same formula that we have seen in the very first video of this mini arc comes from. Okay? Now, in this case, the z is continuous, so that's why we have infinitely many slopes. Now, let's go one step further and let's actually see the second derivative inside. So if I take this further and then find a second order derivative of y with respect now to z, so delta x, delta z, I'm going to finally find that this is simply beta 3. And if you did exactly the same thing on the other side here for the case of the second derivative of y, first with z and then with respect to x, that is also going to give you exactly beta 3. Okay? So this second derivative inside gives you this idea even more clearly that the beta 3 is the rate at which the slope changes, okay? So the rate at which the slope changes. And I'm going to put this in a box so you guys remember it. And this is also like a big conceptual takeaway for you, because here you very clearly see the interaction term is creating like a variety of heterogeneous marginal effects, okay? And it's very clear that the effect of one variable depends on the other variable. In continuous times continuous interaction, keep in mind The marginal effect is now of x is now this beta 1 plus beta 3z, and it varies with z. In the next video, we'll apply this in a work example and compute the marginal effects at different values. So stay tuned, and I'll see you in the next video.